Hi, I'm Peyton. Welcome to Lab 1 Charge Tapes. The objective of this lab was to observe interactions between two charged pieces of tape, and then after these observations were made, we could figure out how much excess charge was on one piece of tape. Once this was done, we could create a computational model using GlowScript. So here are some concepts to understand Newton's second law. In this case, we're going to be using F equals mg, where g is 9.8. We're going to be using Coulomb's law, and we have to keep in mind that the pieces of tape represent point charges with equally distributed charges. So here's some important values to help us make some calculations later. The mass of the tape was 0.0002 kilograms. The length of the tape is zero point 0.2 meters. The length of an atom is 1 e to the negative 10th meters. And then the charge of an electron is 1.6 e to the negative 19th coulombs. All right, so here's some observations and experiment results. So here are some important assumptions and facts. Air resistance is going to be negligible. The tapes are going to be treated as point charges. The charge is going to be evenly distributed along the length of the tape. The system we're going to have is the two pieces of tape, and the surroundings will be everything else around. So in order to charge these tapes, I stuck one to the desk, put another piece of tape on top of that piece, and pulled it off really quickly. This caused the tape to be charged. I did this multiple times so that I could have multiple pieces of charged tape. I found out that two charged pieces of tape repel each other. A charged piece of tape was attracted to a negatively charged pin, and I got this negative charge by rubbing the pin against my shirt. And then a charged piece of tape was attracted to my hand. So the experiment, as you can see to the left, tape A is below tape B, and the separation distance I found between these two pieces of tape was 0.012 meters. The charge on one piece of tape was 5.6 e to the negative 9th coulombs, which is a positive charge. The deficiency of electrons on one piece of tape was 3.5 e to the 10th electrons, and then for every one electron, there were 5.08 e to the 6 atoms. I drew a model here where the red dot is supposed to be tape B, the blue dot is supposed to be tape A as point charges, and as we can see, the electric force points up, the gravitational force points down, and they are balanced out on tape B, which is something that we should also keep in mind because GlowScript should look the exact same. But here how I made my calculations. So the amount of charge on a piece of tape I used by just doing the Q formula with keeping in mind the mass and the radius, and I got 5.6 e to the negative ninth. Now, to find the number of deficient electrons, I had to do the Q that I got previously just there and divide it by the charge of an electron, which we know is 1.6 e to the negative 19th. And that's how I got my deficiency. And then the last thing I did was I had to find the number of atoms, which is just the area of the tape divided by the area of the atom squared. We know the area of the tape is just length times width, and then the length of an atom is 1 times e to the negative 10th, which you just square, and so then you can get for every one electron there are 5.08 e to the 6 atoms, which is the ratio you want. So for GlowScript, I just plugged everything in. I had to start off with my constants, which are just, the length of the tape, the width of the tape, mass, G, K, all of that. And then from there, I could plug in my formulas. Here, I do have the gravitational force being the mass of the tape times G, but the electric force is actually just the absolute value of that. So as you can see below, when I did the Q formula, I put in the electric force because that's what it is. The electric force is just the gravitational force, mg, like we saw on the previous slide. I put in my formulas for the number of electrons, number of atoms, the electrons to atoms, and then the objects section, I just had to pretty much establish all of my point charges and my arrows. The EA is my arrow for the electric force, then my GA is the arrow for the gravitational force. And this should give us a model that looks exactly like what we predicted. Once again, tape B is balanced. It's the one that we drew earlier. We have all of the same values that we calculated ourselves, so everything added up. So some sources of error, the charges are most likely not evenly distributed. We only assumed this to make everything easier. The pieces of tape are not actually point charges. Once again, we treated them like such to make our life simple. Plus, I only saw for one piece of tape and assumed that that Q was equal for both, which is not necessarily true. And during the experiment, my measurement for R was probably not exact, which could throw off my calculations. And with the tape I used, charge could have been lost somewhere along the way, given I used it a good bit. Once again, as you can see, there are point charges to the right. That's most likely, that's not really what they are. All right, so here's our discussion. What if the electrons had a positive charge and protons had negative charge? What would change about the observations you made with your tapes and other charged objects? So despite this change, my observations would have not changed. Even if they switched, how they interact with each other does not. Like charges repel still, and opposite charges attract. So even if the tapes were now negative, that means they would still repel each other given that they have the same charge. And if the pin was now positive, the tape would still attract it because they're opposite charges. So why is it important to handle the charged tapes as little as possible? What happens when the charged tapes come into contact with your hands or other objects? So you're going to want to handle these charged tapes as little as possible so that they don't lose charge. I mentioned this in my sources of error. The ultimate goal is to keep these tapes charged so that you can yield more accurate results. And when coming into contact with my hands or other objects, A lot of times in the environment, these charges are going to be neutral, and we do not want the tape to be neutralized because that's going to cause it to lose its charge. Therefore, we're not going to get accurate results. Um, but our conclusions here is just, we know that like charges repel, opposite charges attract, and we can see this through our model, through what we predicted, and even through our calculations. Thank you so much for joining.